Here they want a list of the elements in A, but they want it in roster form. Roster form uses a set brackets. So it's A, B, C, H, T, W. A, B, C, H, T, W. And that's it. One way to do this problem is the way I've been doing them, which is to list everything in A and everything in B and everything in their union, and then write that down and then do the complement. But let's try using some reasoning instead. What does A union B look like? Isn't it everything that's in both of the circles? The answer is yeah. So what's the complement of that going to be? It's going to be the other stuff that's in the universal set but's not in both of the circles. Well, isn't it pretty easy to see what those things are? They are P, M, and Z. Now, when you're using a union symbol, when you're doing set operations, you need a set for an answer. So this is the answer. It's everything that's in the universe that's not in A or B. The set A minus B is a set, and it's everything that's in A, but subtract off the parts of A that are in B. So it's everything that's in A that's not in the intersection. So it's all the parts of A except for A and H. That leaves B, C, T, W. To my way of thinking, A minus the complement of B is a little bit tricky, so I'm going to list them all even though it takes a while. These are the elements of A. These are the things that are not in B but still in the universe. Now we want to do a subtraction of these two sets. So what we want is everything that's in this first one, but we want to take off any of those things that might happen to be in the second one. So A is okay. B gets taken off with this one. C gets taken off with this one. H seems to be okay. T gets taken off with this T. W gets taken off with this W. So these are the things that are in A that are not in the complement of B. It wants all the numbers in the universe of problem 47. And that includes everything from 1 to 11 that's a counting number or natural number. It wants it in roster form, so we have to write them all out, which is kind of a pain. But there they are. This one's a little bit tricky, so I thought I'd write it out. We want the union of the complement of A and the set B. And so we're going to list all these numbers that are in the universe except ones that are missing from either of these or both of these. And so we have 3. Well, actually we have 2, 3, 4, 5, 6. I don't see 7 or 8, 9, 10, 11. What seems to be missing, so this is the answer to the question, but what seems to be missing are 1, 7, and 8. And if you look at the original picture, 1, 7, and 8 are the numbers that are in A but not in the intersection of A and B. And this kind of makes sense to me because this is the stuff outside of A. And what is the stuff outside of A? Well, if you take a look at this diagram, the stuff outside of A is the stuff inside of B and the stuff outside of both of them. So this outside of A includes everything in here, and then we're uniting that with everything in B. And so if you think about it, this describes everything except the stuff that's in A and not in B. And so this answer makes sense, is what I'm trying to say.